Two engineers are handed the same lattice of coupled oscillators, a photonic crystal, say, or a ladder of inductors and capacitors, and asked one question. How fast does a wave packet on the second band travel? The first writes down the matrix of restoring forces, divides by the inertia, diagonalises, and reads the band speed off the eigenvalue. The second builds the thing and measures it. They disagree by nearly a third. Neither has made an arithmetic mistake. Down the corridor a second puzzle is waiting. A slab whose signal speed varies smoothly across it bends a ray of light, and someone wants to know exactly how much, not to leading order, not in the weak gradient limit, but on the nose. This chapter closes both cases with one instrument. The substrate makes curvature something you compute exactly, with no expansion at all, and it convicts the obvious band speed formula of a systematic, measurable error. The word in the title is doing real work. Exactly. One thing before we begin. Advaita Chakra Theory is a speculative, exploratory framework, not established, peer-reviewed physics. Much of what follows is honest conjecture that still needs validation. Watch it in that spirit as ideas to test, argue with, and refute. Open the file with the evidence already in hand. Chapter 5 built the emergent optical metric. The line element, a long wavelength Goldstone mode, actually rides when the lattice stiffness varies from place to place. Written out, it is minus dt squared plus 1 over c effective squared times dx dx. Two features of that object are load-bearing, and everything in this chapter follows from them. First, the lapse is constant. The time component of the metric is -1 everywhere, no matter what the speed does. Second, the spatial part is conformally flat. The whole spatial metric is the flat one multiplied by a single scalar factor, e to the 2 phi, with phi equal to minus the logarithm of c effective. The speed enters space, and only space, as a conformal rescaling. That geometry is standard analog gravity, imported and not derived here, Unruh, Visser, Barcelo. What the substrate adds is that it supplies the speed field and forbids everything else. Now the first result, and it arrives in closed form. For a conformally flat 3 metric there is a textbook identity giving the scalar curvature in terms of the conformal factor. Substitute phi equals minus log c effective. Use the fact that an ultrastatic metric has 4-dimensional curvature equal to the curvature of its spatial slice, and out drops the answer. R equals c effective squared, times the quantity 4 times the Laplacian of log c effective, minus 2 times the gradient of log c effective squared. That is derived. No approximation is made anywhere, not a weak field expansion, not a slow gradient limit. Any smooth speed profile you like, and this is its curvature on the nose. Here is the honest footnote. An earlier draft of the geometry papers carried the opposite sign on the gradient term, and with it the wrong bending direction. The numerical study caught it. Rays bend towards lower C effective, exactly as in a graded index lens, where high refractive index is the attracting region. The sign is the falsifiable part, and this is the corrected one. So we have curvature. Do we have gravity? No. And the substrate says so in one line. Because the lapse is constant, the Christoffel symbol with 2 time indices vanishes identically, and therefore the time component of the Ricci tensor, R0 is exactly 0. Read what that means physically. A slow test particle feels an acceleration equal to minus that Christoffel symbol, which is 0. No Newtonian force. No clock dilation. The curvature we just computed is entirely spatial. It steers null rays, the lensing is real and quantitative, you can predict the deflection to as many digits as you like, but it cannot pull on matter. Name what is not being claimed here, plainly. This is not emergent gravity. It is emergent optics with an exact metric. The missing ingredient is a genuine lapse, and no choice of speed profile whatsoever can manufacture one. It has to be earned somewhere else in the inertia and locking sector, and that is a later chapter. But the curvature is only as exact as the speed you feed it, and that is where the two engineers come back. On a single channel site there is one Goldstone branch, one speed, C effective squared equals A0 squared J over I, and nothing to decide. The composite chakra of chapter 1 carries several channels per site, so the quadratic theory has several branches, and each branch has its own long wavelength speed. The dynamical matrix is the inverse inertia, times the mass matrix plus twice epsilon k times the stiffness. At long wavelength epsilon k goes like 1/2 k squared A0 squared, so the neighbor term becomes k squared times the real space stiffness matrix. Now the tempting move. Diagonalize that stiffness perturbation on its own, and call its eigenvalues the band speed. It is the first thing anyone writes down. It is wrong, and it is wrong whenever the stiffness and the mass matrix fail to commute, which for a multi-channel site is the ordinary case, not an exotic one. Here is the replacement, and it is derived. First-order perturbation theory for a self-adjoint pencil, done carefully. Treat k squared as the small parameter. At zeroth order, the eigenvectors are not the stiffness eigenvectors at all. They are the mass eigenvectors, the solutions at k equals 0, where the mass matrix alone decides the basis. First-order perturbation theory then says the eigenvalue shift is the diagonal matrix element of the perturbation, taken in that unperturbed basis. So the band speed squared is a Rayleigh quotient V alpha transpose times the stiffness matrix times V alpha divided by V alpha transpose times the inertia times V alpha, not the eigenvalues of inverse inertia times stiffness. The physical statement is compact. The mass term pins the eigenvectors. The stiffness is then merely evaluated on them, band by band. The naive formula would be free to rotate into the stiffness's own eigenbosses, and it may do that only when the mass matrix is degenerate, which is exactly the commuting case. Set the number of channels to 1, and this collapses straight back to chapter 3. Put numbers on both halves. Take an exponential slab, C effective equal to C naught times e to the x over L. The log gradient is 1 over L, its Laplacian is 0, so R equals minus 2C effective squared over L squared. Negative, pure lensing, no attracting well. With unit speed and a gradient of 0.3, R is minus 0.18, and a finite difference general relativity computation on the same metric returns minus 0.18 0, agreeing to 1 part in 10 million. Now the bands. 2 channels, unit inertia, a mass matrix of 2 and 1 down the diagonal, and a stiffness with 1s on the diagonal and 0.3 off it. Because the mass matrix is diagonal and split, the mass eigenvectors are the coordinate axes, so the corrected speeds are just the diagonal entries of the stiffness, both exactly 1. The naive answer is the eigenvalues 1.3 and 0.7, 30% too fast and 30% too slow. Verdict. 2 results, 1 instrument. The exact optical curvature is derived, and its sign is corrected. The conformal identity itself is textbook, but the closed-form curvature of a substrate-supplied speed field with the bending direction fixed is the chapter's own. The mass basis group velocity is derived anew as stated, the multiband group velocity law for any coupled oscillator system with distinct kinetic and potential metrics. That is the falsifiable engineering headline of the whole program, because it is a claim about real photonic crystals, phononic plates and circuit ladders, testable on a bench at room temperature. What stays open? The order k to the 4th continuation, where the mass basis rotates with k and the branches begin to mix, is uncomputed, and it is precisely the regime a real metamaterial reaches near a band edge, and the caveat we flagged does not go away. R0 is 0. This geometry lenses, but it cannot attract. Next chapter, we pay that bill in full. Chapter 7. The R0 equals 0 tax. A word of acknowledgement. This work was inspired in part by the non-dual teachings of Sri Narayana Guru, that the creator, the creation, and the substance of creation are fundamentally one. Symbols from the Hindu tradition, the Sudarshan chakra and the Shivalinga, suggested the analogies behind the chakra model. They are acknowledged as philosophical and symbolic inspiration. The physics stands on its own. Thank you for watching. If this made you think, the book and the next chapter are linked below. Until then, one substance and how far it reaches.